So water is the chapter. Water is the God's gift to all the living creatures from unicellular to multicellular and from plants to animals on the earth. So this is the introduction part, which says that water is important for all the creatures from unicellular, that is from the amoeba, to the multicellular organisms, that is the humans. Water is important for everyone, from the plants to the animals on the earth. The earth's 71% surface area is occupied by water and the remaining 29% by land. So out of the 100%, 71% is water and only 29% is land. So 71% is occupied by water and only 29% is occupied by the land. The oceans contain nearly 97% of water as compared to that available on the earth's surface. So oceans, they have 97% of the water as compared to the one which is available on the surface as underground water or as river water. So surface also does not have that much water. Most of the water is present in the oceans. That is how much? 97% of water. But ocean water, being saline, cannot be used directly for drinking, agriculture and industrial purposes. So 97% is there, water is there 97% in the oceans, but we cannot use this water because it is saline water. It contains salt inside it. So we cannot directly use this water for drinking, agriculture and industrial purpose. Hence we are totally dependent on rainwater, and it is necessary to store the water available from rains. So this 97% is there, but we cannot unfortunately use. Therefore we are only dependent on the surface water, and in the form of surface water we are gifted with the rain water. So we are dependent on the rain water. The quality of water is of vital concern for the humans, since it is directly linked with the human health. So if the water is contaminated, problems are caused like jaundice, which is a water-borne disease. So if the water is contaminated, then problems will arise. Therefore, the quality of water is directly proportional to the human health. So the quality of water is directly proportional to the human health. Human body contains about 60% of the water. How much is the water in the human body? 60%. Water plays an important role in various life processes in the human body. So water is required for various vital life activities inside a human body. In our daily life, water is used for drinking, bathing, cooking and washing purposes. So it is used for drinking, it is used for bathing, it is used for cooking and for washing purposes. Water is also best solvent. So it is called as a universal solvent and is used in many industries such as boiler industry for steam generation, textile, paper, pharmaceutical industries, etc. So water is used in every other industry: textile industry, paper industry, pharmaceutical industry, steam generation industry. For various solutions or slurries as a coolant in power plants and condensers. So water is used as a coolant. When an engine heats, we always put water. Reason is because water is a powerful coolant. It will cool the engine. Reason because of the anomalous properties of water. So water is a universal solvent. It is used in steam generation, textile, paper, textile industry, paper industry, pharmaceutical industries. It is also used as a coolant in power plants. Thus, it is evident that pure water is required by the plants, the animals, and the humans for various purposes. Hence, we need pure water. So, contaminated water, that is the rainwater which falls on the earth, is not in the pure state. So, rainwater is contaminated. Therefore, this rainwater has to be treated before using it. So, this is the introduction. Water is God's gift to all living creatures, from the unicellular to the multicellular, and from the plants to the animals on the earth. The earth's surface is how much percent? 71% surface area is occupied by water. 29 is the land. 97% of the water is present in the oceans as compared to the surface, but we cannot use the ocean water because it is saline. It contains salts. Hence, we are dependent on surface water. And what is the surface water? The rainwater. The quality of water is of vital concern for the human since it is directly linked with the human health. So, human health is directly proportional to the quality. If the water is contaminated, it causes waterborne diseases like jaundice, typhoid. Human body contains about 60% of water. Water plays an important role in various life processes in the human body. In our daily life, water is used for drinking, bathing, cooking, and washing purposes. Water is also the best solvent, also called the universal solvent, and it is used in many industries such as the boiler industry for steam generation. It is used in textile industry, it is used in paper industry, pharmaceutical industries, and it is used as a coolant in power plants, condensers, etc. Thus, it is evident that pure water is required by plants, it is required by animals, it is required by humans for various purposes. Hence, we need pure water. So, contaminated water has to be treated. The rainwater which falls has to be treated up. So, what are the sources of water? The number one source is rainwater. The number one source is rainwater, and the number two source is surface water. So, surface water in the presence of river water, sea water, underground water, and lake water. So, we have rainwater. Rainwater also, by the time it reaches the ground, it becomes contaminated. Therefore, it has to be treated. And surface water is river water, sea water, underground water, lake water. The one which is handy is always the rainwater. So, rainwater is always the handy water. Always it is available. Okay. Then this rainwater only gets accumulated in the rivers, in the seas, as the underground water and as a lake water. So, impurities in water. Pure water shows a pH of 7. So, what is a pH of 7? 7 means a neutral pH. So, pure water has a neutral pH. It is neither acidic nor basic. So, if the numbers are less than 7, we say that the water is acidic. And if on the pH scale it is more than 7, we say that it is basic. But for pure water, it should come 7, neither too acidic nor too basic. Neither acidic nor basic. But when rainwater falls on other surfaces and gets accumulated in the form of water, stores such as river, lakes, etc., it comes in contact with several impurities. So, rainwater is the most available water, and this rainwater only is getting accumulated in the river, forming the river water, in the sea, forming the sea water, underground, seepage, forming the underground water, and lake water. So, this rain water, when it gets stored in lakes, in the rivers, as lake water, river water, it comes in contact with several impurities. Therefore, this rainwater becomes contaminated. This is becoming contaminated. So when the water of the rain gets stored in the river as river water. So it gets stored in the river as river water. It gets stored in the lake as lake water. It gets contaminated because it has many impurities, and the impurities are in the form of minerals, oxides, sulfates, carbonates, bicarbonates, and dissolved gases. These are all the impurities which are present inside of the river water and the lake water, which is nothing but rainwater which has accumulated. So, what is it? As a result, it gets contaminated, and all these impurities will change the characteristics of water. So when it gets mixed with the river and with the lakes, it gets contaminated. And because it gets contaminated, the characteristics of the water will change. Now, this is a very important point. Alkalinity is due to carbonates, bicarbonates, and sulfates. What causes the alkaline nature of water? It is because of carbonates. It is because of bicarbonates. And it is because of sulfates. So it is because of carbonates, bicarbonates, and sulfates. All these together cause alkalinity of water. Cause alkalinity of water. Carbonates, bicarbonates, sulfates. Hardness is due to calcium and magnesium salts. So calcium and magnesium salts called hardness, and hardness is of two types: carbonate hardness and non-carbonate hardness. So one is the carbonate hardness, or we can say as the temporary hardness, and one is the non-carbonate hardness, that is the permanent hardness. So one is the carbonate hardness, that is the temporary hardness, and the other one is the non-carbonate hardness, that is the permanent hardness. So one is caused by carbonates, that is temporary hardness. It can be removed by boiling, by mere boiling. Whereas what is non-carbonate hardness? It is the permanent hardness. It will be removed only by special methods. Boiling cannot destroy permanent hardness. Estimation and removal of hardness is very much essential, as presence of hardness causing salts cause many problems during the use of hard water in industries and for domestic purposes. So we have to remove this water because there will be problems caused because of the contamination of water. Therefore, this hardness has to be removed. So hardness of water has to be removed, otherwise there will be problems caused in industry and domestic purposes. So now I will brief you about why carbonate is called as temporary hardness and why you say non-carbonate as permanent hardness. So we know that temporary hardness is because of the bicarbonates, whereas permanent hardness is because of chlorides, then because of sulfates, okay. So it is because of chlorides and sulfate. This is because of carbonate, CO3, bicarbonate or carbonate. So we call it as carbonate hardness is a temporary hardness. Non-carbonate hardness is a permanent hardness because it is caused by chlorides and sulfates and not by carbonates. So now, difference between hard water and soft water. Soft water gives lather with soap, and hard water is something which does not give lather with soap. Difference we will do it much detail ahead, okay. Hardness of water. Soap generally consists of sodium salts of long chain fatty acids like oleic acid, palmitic acid, and you have stearic acid up. So soap is nothing but sodium salts of long chain fatty acids. And what are these fatty acids? Oleic acid, palmitic acid, and stearic acid up. The soap consuming capacity of water is reduced due to the presence of certain salts of calcium, magnesium, and other heavy metals dissolved in it. So soap consuming capacity is reduced. What is soap consuming capacity? Lathering of soap basically is reduced. Why it is reduced? Because of the presence of certain salts of calcium and magnesium. And other heavy metals may you have ferrous salts, manganese salts, aluminium salt. So these are also these can also cause hardness. These heavy metals can also cause hardness. When the ions of these salts react with sodium salts of long chain fatty acids present in the soap, lather is not produced. So when the ions of calcium and magnesium, they will react with sodium salts of the long chain fatty acid, what will happen? Lather will not be produced. That means the soap will not be consumed. Again, when the ions, kiske ions, ions of calcium and magnesium and other heavy metals, and the heavy metals, when they will react with the sodium salt of long chain fatty acid like the palmitic acid, oleic acid, and stearic acid. So when they react with this, what will happen? Soap will not produce. What will it not produce? It will not produce the lather. No lather. Correct? So it will not produce the lather. That means the soap is not consumed. We say that the soap is not consumed because it is not producing any lather. No lather. But what does it form? It forms an insoluble white scum or a precipitate of calcium and magnesium soaps which do not possess any detergent value. So instead of forming the actual thing, instead of lathering, instead of forming the soap, it does not produce the lather. With the hard water, the soap does not produce the lather with the hard water. Instead, what does it do? It forms an insoluble white scum because of which there is no detergent value. If it would have been soft water, there would be lathering. There would be a detergent value of that soap. But because there is no lather, there is no detergent value. Now the reaction for this goes like this. We have the reaction as C17H35 COONA. What is this? This is sodium stearate. This is sodium stearate. When sodium stearate reacts with CaCl2, now what is CaCl2? CaCl2 is hard. CaCl2, what does it do? It causes the hardness because it is calcium and it is chloride. So what it will produce? It will produce permanent hardness because there is no carbonate. So this is also called as non-carbonate type of hardness. When it reacts, what does it form? It forms C17H35 COO twice Ca. So displacement reaction, Ca goes over here and what you get? Plus NaCl. So plus 2 NaCl. And what is this? This is nothing but calcium stearate, and calcium stearate is nothing but a white PPT. Therefore, I put this down arrow to show that this is a white PPT, and this is what? This is insoluble. So, when C6, C17, H35, COO, Na reacts with calcium chloride, CaCl2, which gives permanent hardness, or the non-carbonate type of hardness, it causes a displacement reaction. What does it cause? It causes a displacement reaction where Ca will go over here and Na will go over here, forming NaCl plus C17H35 COO twice Ca. Why did I put here twice Ca? Very simple. C17H35 COO has one minus charge and Ca has 2 plus charge. So when their valencies will interchange when they will react with each other. So it will be C17H35 COO twice Ca. Correct? Ca is what? Ca is 2 plus Cl is what? Cl is minus 1. So when we react, we write CaCl2. Same way for this also. So sodium stearate is what? C17H35 COO Na. It reacts with what? Calcium chloride, which forms a permanent hardness, gives C17H35 COO twice Ca plus 2 NaCl. The equation 2 is going like this. 2 times C17H35 COO minus plus Ca2 plus, giving you C17H35 COO twice Ca. This is a PPT, and how is this? This is a curdy white PPT. We say it is a curdy white PPT. So again, the same the combination reaction is happening over here. This reaction was displacement, simple displacement reaction. And what is this reaction? This is combination reaction where Ca goes and joins with C17H35 COO minus. Clear? So this is just to show this. How did we get this? It is just for showing the same. Now next reaction is 2 times C17H35 COO Na plus MgSO4. So first reaction mein we took CaCl2. Now we are taking MgSO4. So what type of hardness? So this we know is sodium stearate, correct? Sodium stearate. We know this is sodium stearate. We know this is magnesium sulfate. So magnesium sulfate produces permanent hardness. We know that. Why does it produce permanent hardness? Because there is no carbonate part in it. Therefore, we also call it as non-carbonate hardness. Because only carbonate, they produce temporary hardness. All the other like sulfates, the chlorides, they all produce permanent hardness. So when we react, again we will get a displacement reaction, a simple displacement reaction. We find it as C17H35 COO twice Mg. This is a precipitate, and this name for the precipitate is what? Magnesium stearate. What we call it as? Magnesium stearate. We call this as magnesium stearate. And again we add plus Na2SO4 because valency of Na is plus and SO4 is 2 minus. So Na2SO4. So this is what? This is also a simple displacement reaction. I hope this is this part is clear. So this we took a second example so that things become more clear. That when sodium stearate will react with magnesium sulfate, what will happen? It will form magnesium stearate plus sodium sulfate, causing a simple displacement reaction. This is how you get magnesium sulfate, which is again a white PPT. So we put a downward arrow. So this we will write like this: C17H35COO minus plus Mg2 plus. So this 2 goes over here, this minus goes over here. So we get C17H35COO. 2 comes with this and you have Mg. So this is a PPT and this is also a curdy white precipitator. So we say this is a curdy white precipitator. Now we will see the other thing. What is the other part in this? Let's see. When we talk about the other metals, the other heavy metals, when we talk about these other heavy metals, what are these other heavy metals? I have told you it is ferric. So ferrous. So what are the other heavy metals? It is ferrous. So always remember, when we have variable metals with variable valencies, and in this variable valencies, which block comes? It is the D block which has the variable valencies. The lower one is Us and the higher valency is Ik. So because this is Fe has +2 and Fe has +3. So the +2 one is taken into consideration. Therefore it is ferrous. Then you have Mn2 plus and you have Al3 plus, manganese, and you have aluminium. They also react with the soap in the same fashion and they also will produce the hardness, the required hardness. So not only calcium and magnesium salts, but also the heavy metals like ferrous, manganese, aluminium. These salts also will react and give a hardness. Clear about this other metals point? Next point is what? Next point is so there are certain acids. So we write here further acids such as carbonic acid can also cause free fatty acid to separate from soap solution, and thus contribute to hardness, However, in practice, the hardness of water sample is usually taken as the measure of calcium ions and magnesium ions. So in the syllabus, we will only be concerned with calcium and magnesium. We will not be concerned with the other heavy metals. And we will also not be considered with the carbonic acid. What we will see? We will only see calcium hai, okay, magnesium hai, okay, and we will see the stearate ion, stearic acid. So we will also see the stearic acid, in which we will concern with the sodium stearate only. So this is what is the module for hardness of water. From the next part, we will learn types of hardness. Thank you.